Welcome. In this lecture, we want to get into the fact that the integers are going to be a ring. So what are rings in general? And we're going to kind of start with the idea behind them. So we understand well right? The integers, remember that this means the integers with addition. Right? Because, right, they have like additive associativity. So we have, so addition is associative. So this is going to be associative. Okay, which is that, so here's kind of the example of what we mean by this, which I feel like this is the one that, not until I did advanced math did I ever remember which was associative and which was commutative, so you're not alone in that. If it's also, you always forget this. Okay, so this is like having, so if I have 5 plus, and then I have -3, and then I have the parentheses here, and then I add 12, right, that this is equal to what I would get if I took 5 plus. So I'm just putting the parentheses in a different place. And in fact, you're so used to this, I would guess that you would also, sorry, I have to focus for a second, that this might not even seem like a property. You just know this is true. Okay, but addition is associative, right? It satisfies this. We also have something, an additive identity, which is, I always think of it as like the do-nothing element. Okay, so we have an additive identity. So this is, because we're talking about addition, this is our additive identity. So what do we mean kind of here, which is that we're going to have, oh, maybe I want to actually kind of box this. This is associative. This is identity. Okay, which is that if I was to take -5 and I was to add this additive identity 0, right? So do nothing element, because I would get out -5. Okay, and as another example, so here's another example, which is that if I took on the other side and I went 0, and I added 1002, right, I would still get 1002, right? It doesn't matter. On either side, you add 0, and it doesn't change the element. That's why it's kind of like the do-nothing element, okay? We also have additive inverses. So we have additive inverses. Okay, and so these exist, right? So for each element we have one. So if I take 7 and I add -7, then I get out my additive identity, right? I get out this same do-nothing element. And I also have, right, the additive inverse also works on the other side, right? So I also have, like, I get 0. If I want to take, so if I have -22, then I have to add -22. Okay, so I end up getting -22, which we know is 22, but I do have something that will cancel that. So I have my additive inverses. Okay, and I want to kind of remark here, we have not yet required commutativity. Okay, right, when I'm talking about the properties that we have, I haven't actually said yet that addition is commutative, right? Okay, but because it satisfies these properties, these are going to tell us that the integers with addition is something called a group. Right, but this is rings and fields, so that's a different course. But a very worthy course. And I'm actually going to put a 1 here. And then I'm going to break this apart so that you kind of can see it's a little clearer what are kind of the group properties, and then we'll do what additionally we need to add in order to make it a ring. Okay, so I hope that made some sense, and I will see you in the next lecture.